A warm regards to all. This is Kanimuli VA, Assistant Professor from Sri Ramakrishna College of Arts and Science. Now we are going to discuss about one of the important concept of DBMS, acid properties of a transaction. First of all, what is transaction? Transaction is a set of logically related operations. It contains a group of tasks. We can say a transaction is a unit of work. It is a sequence of work. There are so many operations are performed by a user for accessing the content of a database, but we have to maintain consistency of our database before and after the transaction. Consistency means a balance or a steadiness or correctness. This acid properties the acid properties provide a mechanism to ensure this correctness of our database. Acid is an acronym. Acid stands for A is for atomicity, C stands for consistency, I is for isolation, and D is for durability. Let's see each and every acid properties in detail with example. Look at this example. Here we are having two transactions, transaction T1 and transaction T2. And here account A consists of rupees 600 and B consists of rupees 300. We are going to transfer rupees 100 from account A, and we are going to deposit into account B. So I'm writing the operations like this: read A, read B. We are reading the values, and I'm going to deduct rupees 100 from account A, and I'm going to deposit in it to account B. And finally we are writing the values, write A and write B. So after completion of the transaction, account A should consist of rupees 500 and B should consist of rupees 400. But what happened if the transaction T fails after the completion of first transaction T1 but before the completion of transaction T2? So the amount will be deducted from the account A, but it will not be deposited, it will not be added to the account B. So this problem, this state is called as inconsistent state in our database. So let's see what atomicity, how atomicity will be solve this problem. Atomicity property involves two operations, and, commit and rollback. Commit up. What do you mean by commit? If all the operations in a transactions are completed successfully, then we can commit all these operations. If we are commit the operations, it will be saved in database permanently. But if any of the operation fails in between, then we can roll back all the changes done by previous operations. So these are the two operations which is followed by the atomicity property to solve the inconsistent state of our database. So atomicity property, it state all operations of transaction should be takes place at once. If it is not done with it is not done within a whole unit, then the transaction will be aborted. There is no midway. It means there is no partial transactions. Each transaction is considered as a single unit, and it should be completed as a single unit. If so this type of rule is known as all or nothing rule. This is called atomicity. Next is consistency. The integrity constraints are maintained so that the database is consistent before and after the transaction. The transaction is used to transform the database from one consistent state to another consistent state. The integrity, data integrity means data integrity refers the accuracy of data stored in our database. It describes the data state or data process. It just refer the data quality as well. So the consistency property makes sure that the total value of money in both accounts are same at the start and end of each transaction. So for example, the total amount we are performing transaction in before performing the transaction, the account A consists of rupees 600 and B have rupees 300. So total money in our both account are rupees 900. So after performing the transaction, account A have rupees 500 and account B contain rupees 400. So now also the total amount is rupees 900. So the total amount should not get any deviation before and after the transaction. It means no transaction should not give any adverse effect. It should not give any unfavorable, undesirable effect on the data residing in our database. This is what this consistency property. Next is isolation property. The main aim of this isolation property is transactions should occur independently without any interference. It means the data which is used at the time of execution of a transaction should not be used by the second transaction and until the first one is completed. It means we cannot use the data which is used by the transaction one until the first transaction is getting completed. For example, if the transaction T1 is executed and it is using the data item X, then that particular data item X cannot be accessed by any other transactions. We cannot access that particular data item X until that particular transaction is getting completed. The concurrency control subsystem of DBMS enforce this isolation property, and the concurrency control is one of the database management procedure that is used to control the concurrent operations of a database, and that property also enforce this isolation rule. And then it means even though the transactions are executed concurrently in our database system, this isolation property just make sure every transaction to feel that it is the only one transaction which is executing in the system. So no transaction will affect the existence of any other transactions. The final one is durability property. It means our database should keep all the latest updates even if our system fails or restarts. It means it should hold all the updated information even if in the state of system failure. It means when we have already seen when a transaction is completed, then the data our database reaches a state which is called as a consistent state. So once our database get into the consistent state, then the information which is stored in our database should not be lost. So the recovery subsystem of DBMS has the responsibility of this durability property. The recovery subsystem is one of the procedure which is responsible for implementing the fault tolerance mechanism in our database. The recovery subsystem also ensure the durability property. So this is all about durability property. So far now we have discussed about asset properties. The atomicity, it just make sure each transaction is all or nothing. It just follow the all or nothing rule. And consistency, it just make sure that data should be valid after to all defined rules. It means our database should be in a consistent state even before and after the transaction. Then this is isolation property. It just make sure the transaction do not affect each other. And finally we have discussed about durability property. In durability property, it just ensure the committed data should not be lost even after the system failure. So these all are about the asset properties. Thank you.